A lake effect snow environment is looking increasingly likely going into Sunday and Monday of this weekend. I want to take a moment to look at this, how this works with, lake effect snow, kind of explain how lake effect snow works, as well as just look at the setup because honestly, I haven't really had. I mean, it's just gonna be an interesting setup. There could be a appreciable amount of snow, honestly, anywhere in this region here. Could be northwest Indiana, definitely southwest Michigan at stake, as well as some possible first snows for portions here in Michigan, portions of northern Illinois, Chicagoland region, northwest Indiana, as a few little surface lows are able to develop going into this weekend. So I'm going to be looking at that in this forecast today and just kind of assessing the conditions that will be possible for lake effect snow. The first thing I have here on my screen is actually the lake temperatures. Looking at Lake Michigan in particular, is Lake Michigan's gonna be our particular lake of interest, but keep in mind other portions here, Lake Superior, maybe Michigan Upper Michigan here, this portion of Michigan, really anywhere here, if the conditions are correct for it, could get some lake effect snow. I want to talk about first was how lake effect snow actually works. So on this channel, a lot of the times I talk about severe weather. Instability is something that gets mentioned a lot. CAPE, convective available potential energy, basically storm fuel. And you end up with a very similar thing when it comes to lake effect snow. So with CAPE, you end up with a really warm surface. Let's say, just usually the ground, warm and moist surface. And this leads to more buoyancy, right? You'll end up with a little bit more instability in the region, and that provides a source of lift for any storms that you might get, and then eventually growing into your cumulonimbus storms, which end up precipitating out. Basically, how lake effect snow works is you end up with the same conditions, right? You get a moist surface, which is going to be the lake, because it's water. A warm lake as well, considering that the lake is still within the 50 to 60 Fahrenheit range, especially in Lake Michigan here, being pretty warm. Even I think this is Lake. I can never remember the lakes. Lake Erie out here, almost into the 60s here in some portions. But Lake Michigan in particular is going to be our lake of interest for this event. You'll end up with that warm lake, and again, same conditions, right? This produces a warm and moist surface, and if the air mass going over it is very cold, you end up with a very sharp temperature gradient. You get very warm air near the lake. This is going to be able to rise pretty quickly, and that's how you can get some of that convection to form, which can end up making your little snow come down wherever you are. It's a horribly drawn snowflake, but the point gets across, right? So what you want to see for a lake effect snow case is very warm lakes, which we have, and very cold temperatures going over the lakes. Here's our GFS ensemble run. I'm going to be using this for a little while just because it is the main ensemble I have. We'll look at some other models and how these all play out this event as well. So here's the 850 millibar mean temperature. And we can see basically initialization here. This is basically current. This is our current conditions for the most part. But pretty, warm air advection. It's not really cold, right? Remember the lake being, basically, it's basically 13 Celsius. We're gonna have to work off that a little bit. 850 millibar temperatures right now aren't super duper colder for the most part. We have, 6 degrees, 8 degrees Celsius, not super intense. We also have a little trough here, and as this moves off to the east, you're going to see some northerly winds start to build in here, as well as another short wave out here. Keep an eye on this cutoff low here. So this cutoff low is able to come down, join the main region of troughing out here, and lead to very northerly winds as well as very cold temperatures. You can see definitely sub-freezing, negative 10 Celsius. Considering the lake is 13 Celsius, that's a pretty big lapse rate, all things considered. It's what we call super, I think it's super adiabatic, if I remember correctly. But that's the point where you ended up with like very quick rising ocean, very unstable air mass. And the idea of this is going to continue pretty well. Pretty cold temperatures. I mean, even here into Michigan on Monday, negative 9 Celsius over the lake is plenty of instability until those conditions do eventually kind of die out. Kind of Monday, Tuesday night there, and Tuesday night into Wednesday. Sorry, excuse me, Monday, Tuesday night. Excuse me. To get my time is messed up here. But even then, very unstable air mass is going to come over this lake. I'll look at 500 millibars as well, but the consensus is pretty certain of a very large trough here, very intense trough. Colder air is on its way. This temperature should decrease very well over the lake. So we will have this condition for lake effect snow. The question is going to be where it will occur. So for lake effect snow, the main thing you want to see is a long fetch, is what it's called. You want to see, imagine winds out of the north if you're living here in, either Porter County or Lake County, Indiana. If you want to see lake effect snow, you're going to want very northerly winds because that way you have the most time over the lake for your winds and your air parcels, and that allows for the more instability. Um, and what we have here for our event is going to be a very quick shift from as the conditions begin here, kind of into Sunday. You have a very good westerly component, it looks like here. So portions here in southwest Michigan, maybe kind of north central Indiana, should be paying attention to this. Because at this point you would have lake effect snow ongoing. Looking at our wintertime precipitation, mean snow accumulation, we're going to talk about this a little bit first, but then afterwards you can see along a lot of this Michigan coast and portions here on the Lake Superior coast, you see a lot of that precipitation showing from the GFS ensemble, right? Lake effect snow environment is very much at play. Portions here to the east of Lake Huron as well, just considering it's also, all of these lakes are above freezing, basically all around. And that is going to lead to a good amount of lake effect snow looking pretty possible. Even here, Lake Erie looking possible as well. Portions, Erie, Pennsylvania, maybe even Cleveland if you're able. Portions here in Indiana also looking possible. So let's go and look at some of the deterministic models here. Let's look at how our 850 millibars looks at temperature. You get your little snow system out here, and I do want to take 1 second to mention this as well. Let's look at our precipitation type here. So you end up getting a little bit of a little surface low out here to develop. That will be associated, I believe, with a shortwave trough. Let's actually zoom out. Do apologize. Shortwave trough out here forms. Looks a little bit upstream at the moment, but will form off the Rockies, lead to a little bit of a surface low forming out here. And this will have some moisture associated with it. There is a decent amount of moisture still in the plains. This is going to pick up some moisture, and as it moves into the Midwest, as temperatures become sub-freezing, especially out here in northern Illinois, that is when we might end up with that snow. Looking at precip type here. So you get this little surface low forming, some snow on the backside of it. Do be careful a little bit with our amounts because models like the GFS and NAM like to overdo it a little bit, but you can see where our heaviest snow should probably lie, especially considering the lake temperatures and the moisture associated with that. Wouldn't be surprised if we get some good lake enhancement here in central Michigan as well. Looking at snow accumulations, let's look at 6-hour totals here. Actually, we'll do 24 hours. This will be within a day's worth. Yeah, we'll do total. Why not? Here's basically where that event is ending. You get some of that strongest, bullseye here in Michigan. Some portions here, though, kind of Chicagoland, maybe even getting some trace precip, trace snow accumulations. Portions in Iowa also going to be looking at that. NAM solution, a lot heavier. I do think that this is very much being overdone. I'm unsure what the NAM is really thinking, to be honest with you, but the same idea remains with our main portions. Michigan being the main area of interest for just normal snow. The European model, again, much less bullish it looks like, but you do end up with some traces here out kind of in northern Illinois, Indiana, with more of that appreciable snowfall, kind of in that Wisconsin, Chicagoland, or northern Illinois and Wisconsin region, and some portions here in Iowa. We'll take our short range ensemble forecast as well. This is our probability of snow over an inch, and you can see we do kind of get that portion, a little bit of Iowa, some portions here in Wisconsin, but not too much regarding the northern. Chicagoland does not seem to be getting an appreciable amount of snow in this one. Mean snowfall, and most of it looks to be in Michigan. That seems to be our main area of interest. Regarding lake effect, let's go back to that because, again, this is not a super appreciable snow for portions getting just normal system snow, which is with just that surface low. When it comes to this lake effect, that is when things could really ramp up. Looking at our NAM, remember that the NAM does have quite a lot of snow accumulations, but watch where around that lake where the GFS, actually, the NAM does not get out far enough, where the GFS pours a lot of snow very quickly. Portions here in lower Ontario, northern Michigan as well, and surface winds looking to be, let's go look at that, somewhere in this vicinity, this region being pretty decent for that. And as fetch would probably support snow in southwest Michigan, really just anywhere along the Michigan coast. Instability should definitely be at play. I wonder if Cape even shows up. I don't think it will. Actually, some Cape does exist. You can take a sounding over the lake. You might be able to see how environment looks for snow. It's kind of interesting. I haven't really done this on this channel, but lake effect is its own beast. You can see kind of how this works, right? You end up with this very steep instability due to the lake. And that actually is how you get thunder snow a lot of the time, but for the most part, that steep instability is how you end up with quick snowfall. Look at that lapse, right? 9.2 Celsius per kilometer. Very impressive lapse right there for snowfall. Yeah, below freezing for almost all of the profile. That would help to actually probably get some snow accumulations, keep snow on the ground. Let's look at our, see if how the European model will handle our snowfall. We'll first look at 850 millibars and see how our fetch looks. This run actually ends up giving a lot more of an easterly component to the winds for a little while. You can see winds here are much more northerly, which would lead to heavy snowfall amounts actually more so in like Valparaiso region or LaPorte, somewhere in that vicinity, less on the Michigan end. And let's see how the snow accumulation looks here. Kind of as expected there, and with very heavy snowfall here in northern Wisconsin as well. But look at northwest Indiana here, remember the fetch is like this, and because of the little shortwave the European model has, we end up with lots of snowfall right here, kind of getting hammered in that little region, right? You end up with fairly northerly winds, maybe even the easterly component to the winds, leading to more snow this way, but even then you'd have a lot of snowfall from the European model. So that's the real thing, right? Even look at that, over a foot of snow possible from the European model. But again, taking this with a grain of salt, looking at the European model, definitely an outlier compared to other models. So that's our main update for this, is that the models are not really agreeing on snowfall for the most part. It's clear that there will be a lake effect snow environment at hand, but it's a little bit uncertain of where it will really end up being. There's just enough variability. It makes it really difficult to tell. But you can see that lake effect snow could be viable depending on our shortwaves, how things end up looking. I mean, just everything is very variable. If winds end up being much more northerly, leading to a longer, it's a bad arrow, but a longer fetch from the north of the lake, you could end up with a larger amounts here in kind of LaPorte, Porter County, Indiana, maybe in the lake, but somewhere along this northwest Indiana portion. But if you have even really just the slightest westerly shift, you end up with a lot more along the southwest Michigan coastline, maybe even up here in northern Michigan if it's westerly enough. So I'll keep an eye on this. Just wanted to get some information out there. Again, looks like we're getting our first snows, especially here in some portions of the Midwest. More north seems more likely, portions of Wisconsin and Iowa. Chicagoland looks a little bit iffy. You might get some flakes. Michigan for sure. Definitely this little bullseye down here in the center of this state. But the lake effect snow environment will be at hand. It just depends on where our surface winds and 850 millibar winds allow us to really have it. So, and with that, that's about it for this video. I hope you do enjoy. I just want to get this video out there because I think lake effect snow is interesting. If I can get any interesting looks at it, I might have a little case study afterwards just to kind of see what really happens and understand the environments, because lake effect snow is convective. It's similar in nature to storms, and that makes it interesting. So thank you all for watching, and I will see you all next time.